All right, let's practice. Now, one of the ways in which we talked about exercises in the proof sections of our text was to either go into Tarski's world and see if the conclusion could be falsified while the premises remain true, or to, while in Fitch, take the conclusion of an argument and place it as the inference immediately after the last premise, and then highlight the premises and ask the Fitch program to check whether or not the conclusion was a TOTCon or an FOCon, depending on which version of the system we were working in. The other way that we talked about working most recently was as follows, and I think it's fruitful for a couple of reasons, and I'm going to use it here, and that is namely this. When in the textbook you're asked to determine the validity of an argument before proceeding with a proof after determining that the argument is valid, we're going to pretend that we already know the argument is valid, and we're going to set up a structure according to our standard strategies. As we work along, if we find that the procedure is untenable, we're not getting to the conclusion, we've done everything that we can in terms of following the rules and using specific tactics, that we're not going to get to the conclusion. It just seems clear like the conclusion doesn't follow, and that can play out in a couple of different ways. You then are in a position to submit the create a world and submit it. So that's the approach I want to take here, because if nothing else, it gives us good practice with our strategies. So to that end, I'm going to take the conclusion. I hope that my copy paste will work. It wasn't working the other day. And I'm going to set up the universal intro subproof. So we know that when our conclusion is a universal with the conditional as its connective or its main connective, we set up universal intro of the conditional variety, which means we assume a name for the antecedent, we derive the consequent, and then we exit the subproof and infer that since the arbitrarily named antecedent yields the arbitrarily named consequent, the claim is true of everything in the relevant class or classes. So here, notice that we're given a named relationship, or a partly named relationship, in the way of the consequent of the conclusion, the back of relation. So we just simply assert that in the relevant step that ends the subproof. And then, as usual, recall, we need to provide a name. That's what the drop-down menu allows us to do. This name that's boxed up indicates for the Fitch program that we're using an assumptive name. And then that's the name that we use for, in this case, the small entity. Now, when we look at our premises, we notice that each one is a universally quantified sentence. So one option is to pull off the quantifiers for each of these once you've set up your subproof, and then start working with the resulting compound sentences in propositional logic notation. That is, you're in a position then to work your disjunction, which, as you can see, is the main connective of line 1, your conditional, which is the connective at line 2, and your negation, which is the connective at line 3. So that would be my thinking for the next step. That's particularly the case if, after having set up your structure, you're not 100% sure how you want to go next. In other words, even though it's the case that you know what you're going for, you may not immediately think of the strategy that is employed in cases where your conclusion, in this case it's the conclusion of the subproof, is an atomic sentence, namely set up negation intro. But so go ahead and eliminate here. And what I'm going to do to, I hope, make things a little bit more efficient. And I say I hope because, yay, I was successful in getting the copying and pasting. And what I've done here is just replace all the iterations of the variable with a constant a. Now, why a? Because that's the name I've assumed. And even though I know that I have a pre-given constant c, it's given, again, pre-given, in the second premise. So I just grab that animal and I'm replacing the constant. And one more time, copying and pasting and replacing the variable. So now I'm in a position to see what I'm given. Now, there are 2 points to make here. One is, you know that when you have a disjunction in your premises, you will use disjunction elimination. So you can set that up right away. Alternatively, if you are wanting to get a better sense of the lay of the proof, you can say something like the following. Okay, I see that I have a conditional, and I know that if I have tet A, I can infer back of AC, and once I get back of AC, I'm done with my subproof. I get out and I move to my conclusion. Then the question becomes, okay, well, how do I get tet A? Well, move back to your disjunction elimination. Tet A is is a part of the compound sentence on the right side of the disjunction at line 5. So you should tell yourself, aha, I know that I'm going to have to assume the disjunction elimination sequence so that I can get tet A. You know, again, that your goal is back of AC. Now, the last thing you want to think about is this. You're going to generate a contradiction, right? Why are you going to generate a contradiction? Because you've got at line 7 the negated sentence small a and large a. In other words, the sentence small a and large a is negated. So small a, you already know, is going to be dismantled from the conjunction that's a part of what will be your disjunction elimination. Same thing with large a. So my advice would be the following. Since we decided, rather than working backward from back of AC in terms of a negation introduction nested subproof, we are going to use disjunction elim. So we've got there the following. Cube A, what do we want? We want back of AC. Why do we want back of AC? Because we want to be able to, oops, sorry, I put it in the wrong place. Because we want to be able to get out of the nested subproof and assert back of AC. So since I've already copied it, I'm just going to put it at the bottom of the second subproof. And here's the other side. Let me go ahead and make the font size a little bit smaller so we can get everything, I hope, on at a single glance. For right now, anyway. Now, because I set up disjunction elimination immediately after line 5, Notice that we're going to need to do something. We're going to need to move around the what is now line 14 and what is now line 15. Right? I hope that makes sense. Alternatively, what you could do is this. You could say, oops. You could say, you know, I'm going to start my disjunction elimination after, if I can get to the right place, I'm going to start my disjunction elimination after I have finished eliminating the universals, right? So here's my disjunction at line 5. Here's the beginning of my disjunction elim. And then within each of these nested subproofs, you're reaching up to the relevant lines 4, 6, 7, right? Okay, so now that we know what we're going for at line 11, which is back of AC, let's go ahead and see how it is that we're going to be able to get back of AC. Now we know that back of AC is the consequent of line 7, which means in order to get that consequent, we need to affirm the antecedent, that is, we need tet A. But we don't have that anywhere. In other words, we don't want to assume tet A because that's just going to get us in a double nested subproof, and our question will be, well, how do I get out of that? Instead, what I hope is jumping out at you is the implicit contradiction between line 6 and 4 and 8. And by implicit, I mean the following. Let's dismantle large A from line 8. Let's combine large A and small a, so lines 4 and 9. Small a and large A, right? And now notice small a, large A conjoined gives us a contradiction between 6 and 10. So immediately thereafter, in other words, as soon as we generate the contradiction, we eliminate the contradiction, we assert the conclusion that we want. Now we move to the other side of the disjunction elim, which I thought I had copied already, but I guess not. Maybe I deleted it. Anyway, let me go ahead and grab that side from line 5. Right, so I hope you can see where we're going. We're going to dismantle the conjunction at line 13, which then allows us, by way of 7 and then 14, to get back of AC. Right, so conditional elim. What does that tell us now? Well, look at what we've done. I'm going to darken the proof lines. Take a look at, I'm sorry, I'm going to have to make the font size a little smaller again. At least I thought I was doing that. Okay. So let me delete. So now take a look at where we are. Line 16 brings us back onto the main subproof, that is the structuring subproof of the universal elim. Lines 8 to 12 and 13 to 15 are our, collectively is our nested subproof, which is a disjunction elimination from lines 5, 8 to 12, 13 to 15, right? So disjunction elimination, and then we're out. And remember how we originally began. We said we were setting up a universal intro. I hope that's helpful in I hope this working through this exercise is helpful to you in terms of how we can think through what we do once we set up our standard strategy, or we enlist our standard strategy. I've opened up exercise 13.8. Let's continue talking about and enlisting our strategies and tactics for working with universally quantified sentences in an argument. So here again, we have a universally quantified sentence with a conditional as the main connective, right? So here's a conjunction in the antecedent, and then the conditional, and then an atomic sentence on the consequent side. So what do? Well, we set up conditional introduction for the universal. Now, what that means here, because we have two universally quantified elements, is this. We're going to take the antecedent, and we're going to replace one of the variables with one name and the other variable with another name. Now we're doing this because, as you and I know, whatever is a cube can't be a dodeca and vice versa. So we employ different names. So we use the drop-down menu for A. We're going to add another name, B. These are now our assumptive names. The end of our subproof is going to be the consequent of the conclusion. And again, for the sake of symmetry, I'm employing the A, B assumptive names in the consequent. Then, once you've achieved the conclusion, you're out of the subproof, and you assert that since any arbitrarily named A and B cube and dodeca respectively bears the front of relationship, that every cube is in front of every dodeca. Okay, so now we're in a position to dismantle by our universal, eliminate our universal from line 1. Oops. And we notice that in the case of line 1, right, we have the universal X out front of the sentence, and universal Y is nested. Now, I know that some people find that disconcerting, but remember that the sentence at number 1 is one way to assert the conclusion sentence, and vice versa. They say the same thing, right? Sentence number 1 says, for everything X, if X is a cube, then for everything Y, if Y is a dodeca, X is in front of it. Right? So all the cubes are in front of all the dodecs, or every cube is in front of every dodeca. You'll notice that if, in listening to my asserting the sentence, if you're looking at the conclusion, it's the same thing. All right, so we've talked about this before, but let me reiterate that when it is the case that you have multiple quantifiers at the front of the sentence, you could, Fitch will allow you to peel them off all at once. I mean, I like to do it step by step just for the sake of, showing at each step what has been done instead of making multiple inferences at once. But here, you can't do that, right? You pull off the first quantifier, but the second quantifier is left. So we've got A, but we're leaving the variable Y. There's no way for us to do anything with this universal Y because we've got to deal with the connective. Right now, the connective conditional, the one that's binding the left and the right sides together, is what governs the sentence, right? Up here at line 1, the universal governs the sentence, right? Just like when a negation is out front of a parenthetical, the negation governs the parenthetical. So also when the quantifier is out front, the quantifier is the governing element. Here, it's the conditional. So, as you can probably see pretty clearly, in order to dismantle line 3, we need cube A, which we get from conjunction elimination. Now, at line 5, I'm just going to copy and paste because it's easier. At line 5, we've inferred from, respectively, 3 and 4, the sentence that is governed by the universal quantifier. Now at line 6, we're in a position to pull the quantifier off and instantiate the variable. So I just copied and pasted again. Why am I instantiating to B? Well, the tactical answer is because the assumptive name at line 2 for the dodec is B, and in order for me to work with that sentence, I must have the same name. So you'll probably notice once again that at line 7, I'm going to dismantle line 2, dodec B, which then gets me from line 6 and 7, front of AB, and now I'm done. I'm out of my subproof, and I can assert my universal intro justification. Here we have exercise 13.12. Notice that we have two different quantifiers. We have mixed quantifiers, a universal at line 1 and existential at line 2. Notice also that our conclusion is an existential. We know from our strategies that when we have an existential in our premises, we set up existential elimination. So I've started a subproof, I've assumed the name A, and I'm taking line 2 and giving the existential cube the name A. What's my goal? My goal of the existential elimination 99 times out of 100 is the conclusion, so that I can get out of the subproof and say that from the assumed name A for the cube at line 2, specifically the sentence, it's not the case that A is a cube, right? So sentence 2 says something is not a cube. Sentence 3 says, well, let's assume it's A that's not a cube. If from the assumption that A is not a cube, I can derive the conclusion something is a tet, it follows that from the elimination of the existential at line 2, I've proven something is a tet, so something is a tet. Justification is existential elim. The line citations are the initial existential claim at line 2, and then the subproof. Remember, existential elim is a relative, if you will, a structuring relative to disjunction elimination, right? There is the set off of the subproof by way of a premise. In the case of the disjunction elim, it's a set of successive subproofs. In the case of existential elim, it's one. Now we're in a position to take line 1 and instantiate or eliminate the universal, right? You know that's the case because that's because the sentence says everything is a cube or a tet. That means I can give the everything any name I want. If everything is a cube or a tet, then A is a cube or a tet. Now, what do we know? We know that when we have a disjunction, we eliminate it. Let's assume that A is a cube. If A is a cube, we run into trouble, namely the following. We've just said that A is not a cube. So we have a contradiction. What follows from a contradiction? Well, whatever we want. And what we want is existential tet. Eliminate the, or sorry, exit the subproof and start the next one, right? What are we assuming? That A is a tet. If A is a tet, it follows that something is a tet. So we've just proven from the elimination at lines 4, or the elimination of line 4 at 5 to 7 and 8 and 9, that something is a tet. So that's disjunction elim, which now allows us to get out of our original subproof, right, from 3 through 10, set off by line 2, the existential elim. Okay, let's move on to another exercise. Okay, I have up here the completed proof for exercise 1330. And what I'd like you to do is read through the steps with me and see if what's done makes sense. Part of the reason why I'm presenting it rather than working through it is because I understand that the process of what variable to replace with what name can be a little bit confusing, especially because we're talking about this potentially reciprocal relationship, this liking relationship. So we have line 1, which is very straightforward. Carl likes Max. Line 2 is considerably more complicated. Line 2 says, for every x, if that x is liked by some y or likes some y, then x likes x. Now you and I would read this as x likes itself, but that's not technically what the logic says. All right, now moving on to line 3, let's go ahead and highlight these together. Notice that the universal has been eliminated. Now the universal is eliminated in such a way as to eventually help us enlist line 1 to dismantle the conditional, right? Notice that at line 3, the existential governs the antecedent, right? But the existential does not govern the entire sentence. In fact, we don't even need this. We don't even need this particular open paren around in front of the existential. That might make things visually clearer for you. Notice, so what we want to do is to be able to use line 1 to help us generate the antecedent of line 3, which will allow us to eliminate the conditional. Okay, so that's what we've got. We've got an instantiation or an elimination of the universal and a replacement of each iteration of x with the name Carl. Now, notice how the proof proceeds. The proof proceeds by negation intro. We assume the conclusion, someone likes Carl, is false. From that assumption, we generate a contradiction, so it must be the case that someone likes Carl. And then notice what happens in between. We generate the antecedent at line 5. Let me rephrase that. We begin to generate the antecedent at line 5 by introducing the disjunction. We generalize from max to y so that we can break up the conditional at line 3 by affirming the antecedent at line 6. Then line 7 is partly generalized, right? So if Carl likes Carl, someone likes Carl. That, however, contradicts the assumption at 4. So the assumption is not the case, which means that someone likes Carl. All right, I hope working through these exercises has been helpful to you in reinforcing your understanding of the strategies and tactics that we employ in quantifier logic.